Alright everyone, in this video we'll be implementing the start state for our distance matched locomotion system. If you haven't watched the previous video where we implemented a stop state, I definitely recommend you do, because in that video I spend more time explaining some of the concepts that we'll be making use of in this video dedicated to the start state. With that out of the way, let's get started. In the previous video I pointed out a transition issue between the cycle forward animation and the stop forward animation, where one of the feet would hitch while transitioning between the two animations. I said that I would address it in a video dedicated to syncing. I was mistaken about the cause of the issue, however there still will be a video dedicated to syncing, as that is part of the plan and always has been. But the cause of the issue was actually the settings for the jogging gait. The time it took to stop when jogging was greater than the time it took to stop jogging in the animation. So adjusting these settings so that it would take less time, or more accurately, I should say, that the stop would cover less distance, the transition now looks much better. With that out of the way, which is that both I and at least one of my subscribers, or at least someone who's followed along with the videos, I'm not sure if they're subscribed, have encountered an issue with this automatic rule based on sequence player in-state transition option. When using a sequence evaluator as opposed to a sequence player, the results of having this set to true seem to be somewhat iffy. Sometimes it works, sometimes it doesn't, and I have not been able to pin down an actual cause. It may be an engine bug, I'm not sure, but I'm going to rework this transition for the time being to be based on the character's velocity. I'll get the velocity of the character, specifically the 2D velocity. I'll get the length of that vector, and if it is nearly equal to 0, within an error tolerance of, let's say, 0.1, we'll transition from stop to idle. This means that the last bit of the stop animation will not be played where the character fully aligns with the idle pose, at least in the UUS animation set, but I think the actual transition time itself and the transition blend does well enough. With that done, I'll uncheck the automatic rule based on sequence player in-state option. Now, in the previous video, I neglected to delete a cycle to idle transition. I'll delete it now, as we only want to be able to transition into stop from cycle before going back into idle. It didn't have an effect on the end result of my graph, but it could potentially be favored by the system over the transition from cycle to stop, as the rule set and priority were the same. With that done, we can move on to creating a start state. I'll create a start state within this Locomotion state machine. I'll drive the transition from idle to cycle so that it goes from idle to start. This is new functionality in 5.2. Any version before, create a transition, set it to use the start rule, and delete the old transition. The end result is the same, but the process is much easier with that update that came with 5.2. Now, from start to cycle, we can't use that automatic transition rule, at least right now, as it does not seem to be working with sequence evaluators. There are two general approaches we can take to this transition. I'll be implementing a distance-based transition rule. I'll also show you how we can create a velocity-based transition rule. To begin, I'll enter into the start state, and I'll create a new function bound to when that state becomes relevant. I'll name it setUpStartState. I'll create a new float variable. I'll name it start distance. I'll set this variable to 0 in the setup start state function. I'll create an update function bound to the start state named update start state. I'll get the start distance, and I'll add it to the delta between our current location and our previous location. To calculate it, I'll go into the update location data function. I'll create a new variable, a vector named previous world location. I'll set it before we set our current location, and I'll set it with our current location variable. After we set our previous location and our current location, I'll get the current location and I'll subtract the previous location from it. I'll get the length of this vector and I'll promote that to a variable. I'll name it location delta. Back in our update start state function, I'll add the location delta to the start distance and use the result of that to set the start distance variable. So now we accumulate the difference in position over time each frame that we're within the start state. For our transition rule, I will get this start distance and I will check if it is greater than some value. I will put in 275 and I'll duplicate this greater than node and connect to the start distance variable again. For the second one, I'll put in 150. I'll now get a select node, and for the index, I will plug in our current gate. For walking, if the distance is greater than 150, we'll enter into the cycle state. For jogging, if it is greater than 275, we will enter into the cycle state. We want to adjust these values so that they are the same as or below the distance curve for your start animations with the least magnitude for walking and jogging respectively. The second approach we can take is a velocity-based approach. I'll get our character's velocity 2D variable. I'll get its length. And I will check if it is nearly equal to the max walk speed of our character. Placing a property access node into the transition rule directly will give us an error that won't affect the functioning of our animation graph, but I'd rather do this properly, so instead I'll go into the velocity data function where we update our velocity data. I'll get property access there. I'll call the getCharacterMovement function, and I'll search for walk speed. I'll get the max walk speed float, and I'll promote that to a variable named max walk speed. I'll compile, and back in the transition rule, I'll compare the vector length of our velocity to our max walk speed. If it's nearly equal, we'll return true and enter into cycle. This transition rule works quite well when your acceleration is set to a value lower than your maximum walk speed, which provides some time, and at least a second, for your character's velocity to ramp up to your max walk speed. And that will give you enough time in the start state for the result to look good. If your acceleration is set to be a bit higher, you may want to rely on the distance, though that may not transition as smoothly, and you'll need to rely on sync groups and sync markers to get those transitions looking good, even if the animations line up well. And I'll be covering sync groups and sync markers in a future video. For the time being, I'll go ahead and stick with using the distance-based approach, but I will leave both of these in this graph, and I may switch once we look at the end result at the end of this video. I'll compile, save, and you know what? I'll get another select node, and I'll change the pin type to a Boolean. I'll create a Boolean variable. I'll name it use velocity start to cycle transition. And I'll put it in a category named settings. I'll bring that in and plug it in. Now we can switch between both of these with an actual dedicated setting. I'll compile, and that will be it for this transition rule. Next, we want a rule where we switch out of our start state into our cycle state when our direction enumeration changes. That's simple enough. I'll get our previous direction and our current direction and check if they're not equal to each other. If they're not equal, we'll transition from start to cycle. Finally, one more transition rule from start to cycle. We want to check if our gate has changed. I'll create a Boolean variable and I'll name it gate changed. It looks like I already had a variable in here by accident left over from a previous attempt at recording this video where everything that could have gone wrong did go wrong. So I'll plug that in. Compile. Now back in our thread-safe update animation function, I'll create and place a new function named update character state data. I'll make sure this function is set to thread safe. We want this gate changed Boolean to be set to true for the frame where our current gate and the gate for the previous frame do not match up. Currently, we are only updating our gates when we receive an interface function call from the character blueprint, which updates our current gate variable within the animation blueprint. If we were to try to send a previous gate in, or set the previous gate with the current gate before we update the current gate, both of these variables would only be updated when we receive the function call, and so the previous gate will always be different than the current gate, and so that gate changed Boolean will always be set to true. So instead, I'll create a new function of the gate enumeration type named incoming gate. I'll replace the set current gate with the set incoming gate variable. I'll back out, and in our character state data update function, I will get to the incoming gate, use it to set the current gate, and before that, I will get the current gate and use it to set a new variable named previous gate. We first set the previous gate with the current gate, then we set the current gate with the incoming gate. So now it's possible for these two to be different for a frame before returning to the same value. I'll compare them. If they are not equal, we'll set gate changed to true. We'll do that by plugging the result of the not equal comparison node directly into the gate changed Boolean set node. Now all of our transitions for switching from start to cycle are set up properly. Finally, I'll drag from start to stop and use the shared stop rule. And I'll drag from stop to start and use the shared start rule. And finally, I want to delete the transition between stop and cycle that transitions from stop to cycle. Stop should now only ever transition to start or to idle and be entered into from start and from cycle. Next, I'll go ahead and grab our start layer, and I'll plug that into the output animation pose for our start state. Now in the locomotion layers animation blueprint, I'll copy our full stop locomotion layer, and I will paste it into our start locomotion layer. I'll compile and save. I'll go ahead and remove these two bound functions, and I'll create new functions. One for onBecomeRelevant, named setUpStartAnims, and another for onUpdate, named UpdateStartAnims. For setUpStartAnims, I'll copy the selection code from the setUpStopAnims function. I'll paste it into the setUpStartAnims function, and I'll connect the nodes up properly. Now, in the spirit of speeding up the process, I've duplicated the stop_anim_set variables, and I've renamed each to use the word start instead and put them into their own category. I'll replace the stop variables with the start ones. The original plan was to move on into the UpdateStartAnims function and place our distance matching code there and not to really anything else. However, I encountered an issue that I have not been able to resolve, and it has really bothered me. So if anyone has any suggestions, send them my way, because I cannot figure out why this is occurring. I've encountered a single frame delay in some cases between the base animation blueprint and the locomotion layers blueprint when using property access to retrieve a variable from the base animation blueprint. And in the case of our starts, when selecting a start animation, we transition into the start state on the first frame we have acceleration. This is the first frame that our direction has updated. It was previously set to forward by default to when we'd stopped. Because of this, the direction variable from the previous frame is what ends up in the locomotion layers animation blueprint through property access, and thus the forward-facing start animation is in most cases selected by default. Because of this, I am going to copy the selection code and paste it into the update function. This is not ideal. And the previous method that I showed you, just setting the sequence in a setUpStartAnims function, is the pattern that the Lyra animation system uses in the Lyra starter project. I'm not sure why in this project, following the same pattern, using property access, sending variables between the animation blueprints, things lag behind and the wrong animation gets selected. Don't want this to be unperformant though, and currently we're setting the sequence each frame, and that is not necessary. Instead, I'll get a not equal node and plug that into the select node for our final sequence. I'll go ahead and promote the result of the convert to sequence evaluator node to a variable, and dragging out from it, I'll get the current sequence. I'll compare the current sequence to what this whole chunk of code says we should be selecting. If they're not equal, using a branch, I will set a new sequence. After which, getting our sequence evaluator variable, I will set the explicit time of that sequence to 0. After these two nodes, I'll add a reroute node and connect false into the reroute node. I'll add 2 additional reroute nodes to make this execution line easier to see. Now, if the sequence we believe we should be selecting is different than the sequence we have, we set a new sequence and set the explicit time of that sequence to 0. If not, we continue on. The two conditions that could cause this to change are gate and direction. Our main animation blueprint, when our direction is changed, we exit, but that variable isn't lagging behind in our main animation blueprint, so that transition should function properly. When our gate changes, we exit as well. Therefore, this code should only be used when that discrepancy between our main animation blueprint and our locomotion layer's animation blueprint is resolved a frame after we've entered into the start state. I also plugged the wrong sequence into the set sequence node. I meant to plug in the result of that select node instead of the get sequence function's result. With that finished, I'll go ahead and place in an advanced time node temporarily so that we can test this code out without worrying about distance matching. I'll get our context input, our sequence evaluator local variable, and it looks like I did make a mistake. I accidentally created a sequence evaluator global variable. So I'll delete the instances of it out of this graph, delete the variable, promote the result to a local variable named sequence evaluator, and connect things back up the way they should be. I apologize for that mistake. Next, I'll go back to the base animation blueprint into the animation graph and ensure that the max transitions per frame is set to 1 and the skip first update transition is set to false for this locomotion state machine. Otherwise, the start state will not always play the start animation all the way through with distance matching once we implement that. State machines can be finicky, and setting these settings properly will help to ensure that things work as expected. I'll go ahead and set the animations for the start animation set. You'll set your animations accordingly with whatever your variables and structure look like. If you've been following along with the Lyra animations, you'll have less of these variables as you won't have to differentiate between hips backward into motion and hips forward into motion animations. You'll have simply a jog start animation and a walk start animation variable with 4 slots each. I'll go ahead and set these and we'll return when they are set. Before moving on, when we get distance matching set up, we'll need to make sure that the curve compression settings of our start animations are set to uniform indexable. I showed this process for the stop animations in the previous video, but I'll briefly go through how we can apply the uniform indexable curve compression settings asset that we created to the start animations. I'll navigate into the folder that holds my start animations. I'll filter for animation sequences, select everything here. These are more animations than what I'm using, but we can edit these in bulk, and it's simpler to do it this way than just picking out these specific ones. I'll right-click once they're all selected, go to Asset Actions, and choose Bulk Edit via Property Matrix. Now I'll go ahead and open up the content drawer, and I will navigate into the folder which contains the curve compression setting asset that we've previously created in the stop distance matching video. Here it is right here. To create one, you can just right-click, go to Animation, and then to Advanced, Curve Compression Settings. Inside of it, select Uniform Indexable and save. Though I'll go ahead and delete this as we've already created a Uniform Indexable Curve Compression setting asset. I'll select it in the content browser, and I'll click this arrow icon next to the Curve Compression Settings path for all of these animations, which will use the selected asset from the content browser and place its path here. With that done, the Uniform Indexable Curve Compression Setting asset is selected, so I'll go ahead and save all of these. Close out. Open up the Uniform Indexable Curve Compression Settings asset, and select the compress option. Now, all the animations that we'll be using for the starts are using the correct curve compression, and that will allow the distance matching nodes to work properly with them as they read the distance curve to select the proper frame of the animation to play based on the distance traveled in the game world. Now, if I play, we play the start animation for the appropriate direction. We just need to distance match it now. I'll replace the advanced time node with an advanced time by distance matching node. Unlike the node that we used for our stop state, the distance match to target node, this one takes in a distance traveled over the time span of a single frame and advances the time in the animation from the current explicit time based on the distance traveled. I've also typed in the name of the distance curve for an input. I'll get a property access node, and we've already created that location delta variable, so I'll use it as our distance traveled input. I'll compile, and before we test, I'll go ahead and go back into the start layer, and I want to double check the settings within the sequence player node. So ensure that your settings are the same. The sequence and explicit time should be set to dynamic. Should loop and teleport to explicit time should be set to false. And the reinitialization behavior in this case should be set to explicit time. Additionally, in the setup start animus function, I just remembered we need to make sure that we have a set explicit time function that we call once we set the sequence. I placed that in the update function, but I forgot that it also needed to place it in the setup animus function, as my intention was not to put this code in both functions initially. I'll compile, and in the third person map, I will play. We are distance matching our starts. There's a bit of a hitch for the transition because this is being done distance-based, and so the transition is not occurring at the time it is meant to occur, and we haven't set up sync groups and sync markers properly. So I'll go into the main animation blueprint, and I'll set our setting for using the velocity-based transition rule to true. I find this transition to be less jarring, and I'll actually go into the third-person character, and I think I'll adjust the max acceleration down to 600 as opposed to the 800 it was at. Yep, I do prefer that look. Now, you may have noticed a spin between the start and our cycle, as currently the setup cycle state function sets our current hip-facing direction to our desired hip-facing direction. I'm going to go into this function and I'm going to rename it set hip facing as desired. And I will go into the start state. And because we already have two functions bound to this output node, I'll go ahead and toss the set hip facing as desired function to the on become relevant binding for the start locomotion layer. Now we play the proper start as our hip facing gets set as soon as we begin moving, as it would only make sense that our hip facing is set to our desired hip facing. This is not a step you'll need to take if you were following along with the Lyra animations or another animation set. It does not have hips forward into motion and hips backward into motion for the right and left strafing directions. Finally, we'll take a look at the starts with our walk gait. The transition is a bit jarring as we increase our velocity more quickly when walking. Again, we can adjust our gait settings. I'll change the maximum acceleration. Let's try the same as our max walk speed, 250. I think a lower rate of acceleration compared to our maximum speed is acceptable here, as it's a slower movement mode overall. It looks like there's a bit of an issue when exiting this state and stopping while walking. In my case, the issue is actually with the distance curve in the walk-stop animation. Reapplying the modifier using the same technique that I showed in the dedicated video to distance matching stops did the trick. Playing once more, we can see that the walk stops function properly. In the case of the walk backwards animation, I had the deceleration set too low, and again, the distance was longer than the distance traveled in the animation. Same issue we had before when jogging forward and stopping. All right, everyone, that is going to be it for this video. And in the next one, we'll be creating the pivot state for our locomotion system. And be sure to leave any questions you have in the comments or in the Discord server linked in the description below. Thanks for watching.